Very well. So just before we take care of the pitch up and down, I just noticed something. We're not really controlling kind of a maximum limit, right? We're not clamping that value if it gets too strong, right, for the right or left, for the velocity of the yaw. I think we should do that, right? So after everything, after I set the velocity right here, let's just do a little test right here. So if we are beyond a threshold, right, a maximum threshold, so for example, if the ship dot velocity yaw is, let's just say, less than minus, let's say, 2048, then the ship velocity yaw receives always minus 2048, right? And also, if it is greater than positive 2048, then I also force it to be positive 2048. And I really don't need this positive, but you get the idea. Right, so this should be enough for us to kind of clamp the value into this maximum and minimum values, right? Just force it to be in this range of values. And let's just think about the pitch quickly here. So if I am pressing up, what do I do with my pitch? So I'm going to have to change the velocity of the pitch, right? So that means that ship dot, you know what? Maybe we don't even need to do that for the pitch. I think I'm going to be lazy. And you know, let's just consider the pitch different, right? We don't need to have this velocity change of the pitch. Let's just say that the pitch, if I press up, pitch decrements by, I don't know, a very small value, 6, and if it is down, 6. So I'm just going to be lazy right now. If you want, you can go ahead and put the velocity. I'm just going to save some time and say that the pitch is going to be like that. And let me just see. So it really doesn't even make sense for us to have this velocity pitch right here. But I'm just going to leave it like that. That's fine, right? Velocity pitch right now is always 0. I think that's okay. Right, so I think this is okay. Let's just test that maximum of the yaw as well. So we should be able to go up and down by this 6 value. So if I go front, I go like this is fine. I have a maximum now. If I turn to the left, I should have a maximum value. And if I go up here, the pitch changes, right, a little bit. So, right, so we have some clipping. We're going to have to, so if I go really, really fast, right. Okay, so we're updating. If I go up, if I go down. Yeah, this looks okay, I guess. It's just I'm mostly interested in the yaw movement, right? So I can still go up and down with the pitch. I think it doesn't look that bad. Right here we have that big drop. It goes and drops. Okay. Rotation. If I go up with my pitch, see, up and down with the pitch, does not look that bad. So I think we can get away with not even using velocity and acceleration for the pitch, just for the yaw. That's okay. Cool, so I think that's it. See, yaw to the right, yaw to the left. Now we have this other section here. Cool. I am going to stop right now. And I think one of the last things that I want to do is something that I know that the original game did was, I know that one of the effects that it did was if you were turning yaw to the left or right, it created this almost like this kind of anti-gravity thing that if you went to the right, it changed a little bit of the row. So you have this effect of, you know, if you go to the left or right, the row changes a little bit as well. So I think that is something that we can think of, right? So if I'm changing to the right, this movement to the right, maybe we can have a kick on the row as well, right? So we change the row as well to go to the right. And then if we go to the left, we change a little bit of the row to go to the left. You see, I'm rolling a little bit as I'm turning right or left. that is something that I think we can implement. Let's just do that in the next lecture. If we think about changing in the yaw left or right, and also account for this change in the values of the row, positive or negative, I think we can achieve this effect. I think that's going to look nice in our implementation. Right? This is just a little toy project, but it's nice to achieve this kind of physics effects based on this, especially because we're using fixed point math, right? I want us to train these ideas of converting the values, multiplying these numbers, right? These numbers, they are not usually what you think of as floating point values. It's nice for us to have these physics movements using fixed point math. So that's what we're going for.